Can you see the screen now? Hello, you have to respond.
Yes, sir.
And is it moving to the next screen?
Yes, sir.
Please. Okay. So we are now in the third day of inverse trigonometric functions. We have defined inverse of sine, inverse of cos, inverse of tan. Now we go for inverse of cot. That is now, you know the domain of cot function? Domain of cot function is r minus k pi. K belongs to z, and the range of cot function is r. So r minus k pi, k belongs to z, to r is onto but not one to one. But not one to one. So what is the usual procedure? To make it one to one, we restrict the domain. And now to restrict the domain, we look into the graph of cot function, y equal to cot x. It is not defined at minus pi, not defined at 0, not defined at pi. And you can remember, we have discussed the graph of y equal to cot x. It is something like this: a line parallel to x-axis may intersect the curve more than once, and hence it is not one to one, right? It is intersecting more than once. Now we have to take up some portion of the graph or portion of the curve, some domain where the graph will not be intersected by a horizontal line more than once. What are the options? We may take, say, minus 2 pi to minus pi, open interval. Remember, it is not defined at integer multiples of pi. Or other option, minus pi to 0, or option 0 to pi, and so on. Maybe pi to 2 pi, and so on. Now, among them, we take up the 0 to pi open interval as the principal domain, right? So the principal domain for sine was closed interval minus pi by 2 pi by 2. That for cos was closed interval 0 pi, and that for tan was open interval minus pi by 2 pi by 2. Now for cot, we have the open interval 0 pi. So open interval 0 pi is the principal domain for cot. So that means cot from 0 pi open interval to r is a bijection, and hence its inverse, cot inverse from r to 0 pi is defined. So that now we know cot of cot inverse x equal to x for all x in r, whereas cot inverse cot y equal to y for all y in 0 pi. Remember, it is for all y in 0 pi only. Further, if y equal to cot inverse x, if cot y equal to x, where x belongs to r and y belongs to 0 pi, we take care of that. Now, cot inverse from r to 0 pi is called the principal value branch. We can discuss some other branches. Maybe r cot inverse from r to pi 2 pi, 2 pi 3 pi, minus pi 0, and so on. R to minus pi 0, r to pi 2 pi, and so on. Several principal other branches. Cot inverse 1 is pi by 4 because cot pi by 4 is 1. Cot inverse 0, pi by 2 because cot pi by 2 is 0. Cot inverse root 3, you have to remember pi by 6 because cot pi by 6 is root 3. Cot inverse minus 1, can somehow we say minus pi by 4, cot minus pi by 4 is minus 1, correct, but minus pi by 4 is not in the principal domain. It will be 3 pi by 4 because minus pi by 4 is not in the principal domain. Only 3 pi by 4 is in the principal domain. Right? Cot of cot inverse x equal to x for all x. There is nothing special. Cot of cot inverse 5 is 5. Cot of cot inverse anything. Cot of cot inverse any real number is the same because it is true for all real values. Whereas cot inverse cot x is x, or cot inverse cot theta is theta, only if theta belongs to 0 pi. 3 pi by 5 it is true, 2 pi by 5 it is true. What about minus pi by 7? Cot inverse cot minus pi by 7 is not minus pi by 7 because minus pi by 7 is not between 0 to pi. But now let us see how we define it. Cot theta plus pi is cot theta, you know it. Cot theta plus pi is cot theta. You can use this anywhere. Cot theta plus pi is cot theta. Tan theta plus pi is also tan theta. So minus pi by 7 plus pi, that is cot minus pi by 7 is as good as cot minus pi by 7 plus pi. And minus pi by 7 plus pi, on simplifying, you get 6 pi by 7. So cot inverse cot 6 pi by 7, which is equal to 6 pi by 7. Okay? Graph, you can plot the values, very simple. It is between 0 to pi, open interval 0 to pi. And plotting the value. The graph of y equal to cot inverse x look like this. Graph of y equal to cot inverse x look like this. Okay? Further, inverse of sec function. The range of sec function is r minus open interval minus 1 1. That means it can be any number less than or equal to minus 1 or any number more than or equal to 1. And the domain is sec is 1 by cos. So domain is r minus odd multiples of pi by 2. So if we take sec function r minus odd multiples of pi by 2 to r minus minus 1 1, it is onto but not 1 to 1. Now to make it 1 to 1, we'll have to restrict the domain. For that, let us look into the graph. See, graph is playing major role. This is the graph of y equal to sec x. Graph of y equal to sec x, and not defined at odd multiples of pi by 2, not defined at minus 3 pi by 2, not defined at minus pi by 2, not defined at pi by 2, not defined at 3 pi by 2, and so on. Now we have to look at what portion of the graph or what portion of the domain we can select so that horizontal line will not intersect the graph more than once. Here it will intersect. Remember, okay? Horizontal line, if at all intersecting actually between minus 1 and 1, there is no graph, so there is no horizontal line needed there. Other horizontal lines intersect more than once. So what we can take is that you cannot take minus pi by 2, pi by 2. There again graph will intersect twice. One of the options is you can take, say, minus pi to 0, but it is not defined at pi by 2. So what we do is that minus pi to 0, but exclude minus pi by 2. Minus pi to 0 is closed interval. It is defined at minus pi, it is defined at 0. Minus pi to 0 closed interval, but remove pi by 2. I mean minus pi by 2, remove minus pi by 2. That is one option. Other option is you may take 0 to pi closed interval, but remove pi by 2, because it is not defined at pi by 2, not defined at pi by 2, not defined at pi by 2. Or we may take 0 pi to 2 pi, but then not defined at 3 pi by 2, and so on. We take the principal domain as closed interval 0 pi, but not pi by 2. The principal domain of sec function is, remember, closed interval 0 pi, but not pi by 2. That for sine was closed interval minus pi by 2, pi by 2. For cos was closed interval 0 pi. For tan was open interval minus pi by 2, pi by 2. And for cot it was open interval 0 pi. Now for sec, slight difference between them. Closed interval 0 pi, but not pi by 2. So now let us define the sec function. Closed interval 0 pi minus pi by 2 actually means 0 to pi by 2 exclusive, 0 inclusive, union, say 0 to pi by 2, union, pi by 2 to pi by 2 is not included, okay. Now let us define the inverse of sec function. Sec from 0 pi minus pi by 2 to r minus 0 pi minus 1, I mean r minus 1 is a bijection. Hence it inverse. This will be the domain for the inverse. R minus 1 to codomain, that is 0 pi minus pi by 2 is defined so that sec of sec inverse x is x for all x in r minus 1. Sec inverse sec y is y for all y 0 pi minus pi by 2. And moreover, we can easily see that y equal to sec inverse x. If sec y equal to x, more importantly, x must be member of r minus minus 1 1 and y must be member of 0 pi minus pi by 2. Okay, take care of this. Principal value branch is sec inverse from r minus minus 1 1 to 0 pi minus pi by 2. That is the principal branch. Can one of you tell me any other branch? Some other branches I am going to write here. Can you tell me one other branch? Domain will be same, r minus minus 1 1 2. Can I hear from you? Any other branch?
Minus pi to 0.
Minus pi to 0, but something to be excluded.
Minus pi by 2.
Minus pi by 2. Minus pi to 0, remove minus pi by 2. That is minus pi to 0 minus pi by 2. Or pi to pi minus 3 pi by 2. Minus pi to 0 minus pi by 2. Or pi to 2 pi minus 3 pi by 2. And so on. You can have various other branches. Examples are very simple. Sec inverse 1 is 0 because sec 0 is 1. Sec inverse root 2 is pi by 4 because sec pi by 4 is root 2. You know, cos pi by 4 is 1 by root 2. So sec pi by 4 is root 2. Sec inverse 2 by root 3 is pi by 6 because sec pi by 6 is 2 by root 3 because we know cos pi by 6 is root 3 by 2. Sec inverse minus 1 will be pi because sec pi is minus 1. Sec inverse 0. Who will tell me sec inverse 0? 0? Come on. Should I tell the answer? Hello? That is sec inverse 0. I'm going to tell if you don't say. Sec inverse 0 is not defined because, you know, sec theta can never be any value between minus 1 and 1. Sec theta can be either 1 or more or minus 1 or less. Sec theta can never be equal to 0. Sec inverse 0 is not defined. Okay, further. Sec of sec inverse 1 is 1. This is true for all values between less than minus 1, less than or equal to minus 1, more than or equal to 1. But not at 2 by 3. Sec of sec inverse 2 by 3 is not 2 by 3 because 2 by 3 is less than 1 and more than 0. It is not in the domain of sec inverse. Right? It's not in the domain of sec inverse. Well, now it's not defined. Sec of sec inverse 2 by 3 is not defined. Sec inverse sec theta is theta or sec inverse sec y is y if y belongs to 0 pi minus pi by 2. Sec inverse sec pi by 5. Sec inverse sec pi by 7 is pi by 7. Sec inverse sec 2 pi by 5 is 2 pi by 5. Sec inverse sec 3 pi by 5. What is the value? Remember, 3 pi by 5 is less than pi. Less than pi. It is between 0 to pi. It is 3 pi by 5. It's no doubt. Be strong. Be strong. You have to be careful about that. Sec inverse sec 3 pi by 5 is 3 pi by 5 because 3 pi by 5 is a member of. What about sec inverse sec minus pi by 7? Remember, minus pi by 7 is not here. It is not minus pi by 7 because minus pi by 7 is not a member of this at all. But that is defined. You know, sec is an even function. Sec of minus theta is sec theta itself. So sec inverse sec minus pi by 7 is as good as sec inverse sec pi by 7 and hence it is pi by 7 because cos minus theta is cos theta, same way sec minus theta is sec theta. So sec inverse sec pi by 7 is pi by 7. So sec inverse sec minus pi by 7 is sec inverse sec pi by 7, which is equal to pi by 7. Okay. Graph of y equal to sec inverse x. You may try to plot. I'm only just drawing it here. It is not defined at pi by 2. It will be between 0 to pi, but not at pi by 2. In the values, graph of y equal to sec inverse x look like this. Graph of y equal to sec inverse x. Graph of y equal to sec inverse x. Okay. Now inverse of cosec function. Now the thing I can repeat, so I can go fast. The range of cosec function is r minus minus 1 1, and the domain of cosec function is r minus integer multiples of pi. So cosec from r minus k pi, k belong to z, to r minus minus 1 1 is 1 2, but not 1 to 1. What will you do to make it 1 to 1? We restrict the domain. For that, we look into the graph. Graph of y equal to cosec x. Y equal to cosec x. It is not defined at integer multiples of pi. It is not defined at minus pi, not defined at 0, not defined at pi, not defined at 2 pi, and so on. So here the line, horizontal line will intersect more than once. So which portion you take? Normally we cannot take 0 pi, because in 0 pi the line, the horizontal line will intersect more than once. We can take various option, minus 3 pi by 2 to minus pi by 2, but exclude pi, or minus pi by 2 to pi by 2, exclude 0, minus 3 pi by 2 to pi by 2, minus 3 pi by 2 minus pi by 2 to minus pi, minus here, minus pi by 2, minus pi by 2, pi by 2 to minus 0, right? Or pi by 2 to 3 pi by 2, here there is a minus missing, here is a minus missing. Okay. Well, we take the principal domain as minus pi by 2, pi by 2, minus 0. See, there is difference in all now. Cosec, the principal domain is closed interval, minus pi by 2, pi by 2, but not 0. It is a principal domain. So we define now cosec from minus pi by 2, pi by 2, minus 0 to r minus minus 1 1 is a bijection. Hence its inverse from r minus minus 1 1. The domain of cosec inverse is the range of cosec, that is r minus minus 1 1. And the range of cosec inverse is the domain of principal domain of cosec, that is minus pi by 2, pi by 2, minus 0 is defined. Now you know the routine steps. Cosec of cosec inverse x equal to x for all x in r minus minus 1, and the cosec inverse cosec y equal to y for all y in closed interval minus pi by 2, pi by 2, minus 0. We also know that y equal to cosec inverse x. If cosec y equal to x, x must be member of r minus minus 1 1, and y must be member of minus pi by 2, pi by 2, minus 0. Okay. These things you take are all 6 inverse trigonometric function are different domain and different ranges. Okay. Domain, there are uniqueness in, say, sine and cos inverse, same domain, the range different, or the principal domain for these trigonometric functions will differ. You take care of that. Cosec inverse from r minus minus 1 1 to minus pi by 2, pi by 2, minus 0 is called the principal value branch. Other branches are written here. Minus 3 pi by 2, r minus minus 1 1, that is same. Minus 3 pi by 2, minus pi by 2, minus pi, or pi by 2, 3 pi by 2, minus pi. All these are other branches. We can have various other branches, right? Cosec inverse 1 is pi by 2, cosec inverse root 2 is pi by 4, cosec inverse 2 is pi by 6. More values I will put as exercise for you. Sec inverse minus 1 is cosec, not sec, cosec, missing cosec. Take care of that. Cosec inverse minus 1 is pi by 2 minus pi by 2 as cosec minus pi by 2 is minus 1. Cosec, not sec inverse, cosec inverse minus 1. Cosec inverse 1 by 2 is not defined because you know cosec theta cannot be 1 by 2. Cosec theta cannot be 1 by 2. Cosec theta can be either more than or equal to 1 or less than or equal to minus 1. Okay. Further, the same way, cosec of cosec inverse x is x if x is either 1 or more, it is 2 at 1, it is 2 at 15, but not 2 at 2 by 3. It is not defined. Okay. Well, cosec inverse of cosec pi by 5 is pi by 5. Cosec inverse of cosec 2 pi by 5 is 2 pi by 5. Cosec inverse of cosec minus pi by 7. Remember, minus pi by 7 is within the range of cosec inverse. It is in the principal domain of cosec. So it is 2 minus pi by 2 minus 0. Whereas cosec inverse of cosec 3 pi by 5, that is beyond this. It is actually 3 pi by 5 is more than pi by 2. But we can find the value. Cosec 3 pi by 5. Cosec 3 pi by 5. Cosec pi minus theta is cosec theta. Cosec 3 pi by 5 is cosec pi minus 2 pi by 5. Pi minus 2 pi by 5 is 3 pi by 5. And cosec pi minus theta is cosec theta. Cosec pi minus theta is cosec theta. So this is cosec inverse of cosec 2 pi by 5, which is nothing but 2 pi by 5. See, cosec inverse of cosec 3 pi by 5 is 2 pi by 5. Clear? Graph that you draw. If you have a doubt, you can refer here. It is not, it is from minus pi by 2 to pi by 2, but not defined at 0. Okay? Further, find the value of, well, once again, the domain is a domain of cosec inverse is r minus minus 1 1. Remember, domain of cosec inverse is r minus minus 1 1. It is not defined. Cosec inverse is not defined from minus 1 1. The value of cosec inverse may lie from minus pi by 2 to pi by 2, and cosec inverse cannot be, right? 0. Minus pi by 2 minus 0. Okay. Now let's take one exercise here. Cot inverse, find the value of cot inverse cot 19 pi by 6. How to evaluate cot inverse cot 19 pi by 6. 19 pi by 6 is much beyond the principal domain of cot 19 pi by 6. What we do is that this 19 pi by 6 we are going to reduce and bring it in the first quadrant or in the principal domain of cot. Principal domain of cot is open interval 0 pi. So what we do is that is 19 pi by 6. 19 nearest multiple of denominator 6 is 18 pi. 18 pi plus pi by 6. See, 19 pi I have written as 18 pi plus pi. Why 18 pi? 18 is the nearest multiple of 6. The advantage is that 18 pi plus pi by 6 I can write 18 pi by 6, that is 3 pi plus pi by 6. 3 pi plus pi by 6. And cot 3 pi plus theta is cot theta. Cot 2 pi plus theta, you remember cot theta plus any integer multiple of pi. Cot theta plus any integer multiple of pi is cot theta. This is true for tan also. So cot 3 pi plus theta is cot theta, that is cot pi by 6. Cot inverse cot pi by 6 is pi by 6. We'll share more problems on the line. Try a few of these. Very simple, straightforward. You have to answer all these questions. Further, you have questions something like this. 19 pi by 7. Nearest multiple of 7 will be 21 pi. Here, 17 pi by 5. It will be nearest multiple of pi will be 15 pi. 9 pi by 5. It is actually 2 pi minus pi by 5. 21 pi by 5. This you try to evaluate. If you have difficulties, you can share the difficulties with me. I will bring out. I will take care of your doubts on the way. Draw the graph of y equal to cot inverse x. Draw the graph of y equal to sec inverse x. Draw the graph of y equal to cosec inverse x. And you draw only the principal value branches. Only the principal value branches. Okay? Any question you can ask me. Anything which is missed out or any queries you have, please bring out in my notice and try to do all the questions. Try to do all the questions which I share for you. Whatever is left out. Ashwin, your doubts actually I is solving. I think you joined a little late. If you have still queries, you can ask me. Right? All these are solved here. If you want, you can take a note. I can take a screenshot of this. Okay? Still, if doubt remains, you can ask me. I'll bring out the solution for you. All the best. We'll have a nice day. Well, we'll meet Monday with